So in this session I cover introduction to the alternator and the construction of alternator and these are the content which I discuss in this session. So introduction to the alternator, so where the alternator is used, and the principle of operation of alternator. So the principle of operation of alternator is similar to the DC generator, so which is Faraday's laws of electromagnetic induction. Same principle here, but in the DC machine, poles are on the stator and the winding is on the rotor. But in the AC generator or alternator, poles are on rotor and armature winding on stator. So that is a change. That is a difference between DC generator and alternator. And I will explain the difference later. So next one is construction. The construction of alternator. So construction is stator construction is having armature. So rotor is having poles, and there are different types of two types of alternators are available. One is salient pole, and another one is non-salient pole alternators. So this is if you use a salient pole rotor, such a alternator is called salient pole alternator. If you use non-salient pole rotor, and that alternator is called a non-salient pole alternator or cylindrical, nothing but a non-salient pole alternator. So for both of these two, stator is common. Stator construction is common. There is no difference. And the phase sequence, and what is phase sequence? The order of production of maximum EMF of RYB phases. So this is a phase sequence, and so these are the contents which I discuss. So first of all, introduction to the alternator. So this alternator is also called as a synchronous generator. Synchronous generator, synchronous generator is called as alternator because this generator will provide the produces the frequency, constant frequency, that is Pn by 120, and the speed of the alternator is 120 f by p. This speed is nothing but synchronous speed. This is fixed speed. That's why this rotor and stator magnetically stable. That's why this is called synchronous speed. And this speed ns is equal to 120 f by p. This is fixed frequency and fixed poles. The electricity which is generating is called synchronous generator. And generally this alternator converts mechanical energy to the electrical energy electrical energy, and by keeping voltage and frequency constant. This is the condition. So it should run at a constant speed, nothing but the nuclear power plant and hydel power plant, thermal power plant, all in all generating stations, this alternator is available. This must rotate at a constant speed. Then only this is called as a synchronous generator. Then only this is called as a synchronous generator, because it is generating electricity at a constant speed. That's why this is called synchronous generator. Speed always constant. If you hear the word of synchronous, then we can say, always we can say that speed is constant. That's what we need to remember. So working principle is similar to the DC machines. That is Faraday's laws of electromagnetic induction. Whenever this is a Faraday's laws of electromagnetic induction is whenever flux cuts the conductor, or conductor cuts the flux, and EMF induces across that conductor. So in DC generator, In DC generator, conductor cuts flux, but in alternator, flux cuts conductor. That is a difference. So but Faraday's law uh, explains us whenever conductor cuts the flux or flux cuts the conductor, of any one of the case should be possible. Such a uh, that is called Faraday's laws of electromagnetic induction. So and also induced EMF, E is equal to B L V sine theta. Theta is the angle between flux and conductor. So you can see this is flux, and this is L, nothing but length of the conductor. This is L is nothing but a active length of the conductor. So for example, this is north pole and this is south pole. Look at this one. So the flux is north to south like this. These are the end I am taking. Flux is linking only from this area only. That's why this part and this part is not a active part of the conductor, because induced EMF in this area, induced EMF is not possible. So that this L decides active length of conductor, active length of the conductor. So that this is BLV sine theta is the induced EMF found in the alternator. And the principle of operation is so the rotor of the generator driven by the prime mover, and the prime mover is connected to the turbine. Turbine is mechanically coupled to the alternator, so that will rotates, and a DC current flows in the rotor winding. So DC current flows in the rotor winding, so which is set up flux flux. So rotor, the flux establishes in the rotor. So if you rotate the rotor with by the help of turbine, this flux will rotates, and it will cuts the stator flux, and which produces a rotating magnetic field within the machine. Nothing but after cutting the RYB phase winding, it will produce as a rotating magnetic field. So the rotating magnetic field induces the three phase voltages in the stator field winding. So that first of all, the rotor is having a rotor flux, which will cuts the stator winding, because rotating flux cuts the stator winding. Stator is stationary, and it will produces the three phase voltages in the stator, three phase voltage stator, and it also produces a rotating magnetic field. So whatever the three phase generating, or if we are giving the three phase to the motor, then definitely three phase rotating magnetic field will be induces. So if you cuts the rotor stator winding, three phase stator winding, it will produces the rotating magnetic field. This rotating magnet will be induces. In the same way, if you give the three-phase supply RYB three-phase supply given to the synchronous motor, it will produce a rotating magnetic field. Rotating magnetic field. If you give the three-phase supply to the induction motor also, three-phase induction motor also, it will produce a three-phase rotating magnetic field in the rotor. So this is let us discuss the construction. So it is having a rotor, and this is stator. Stator is having the armature winding. armature winding Armature winding is having in the stator. Look at this one here, field winding is a rotor is having field winding, so which will produces the flux. And the stator, which is having armature winding. This armature winding induces the EMF, three-phase EMF. So these are the protection. So to protect the stator and rotor, we have end covers, and this is also end covers and fitted with the revolts, and these are the bearings. Look at this one here. Bearing is available. So this bearing, by using this bearing, that rotor will rotate very smoothly. So this is a stator construction. If you look at the stator construction, stator slots will be three types of slots will be, and open type, closed type, and semi open type. So open type slots and closed type and semi open type slots are used, and these are the slots generally. Among these two, semi open type slots are used. Slots are used in the stator construction, and in the stator slot, stator winding will be placed, and that winding ending terminals will be taken outside. Such a terminal appear in the terminal box, and this is a eye used to lift the motor with the help of machines or mans, whatever it may be. And this is stator core. The stator core is made with laminations. Stator core is made with laminations to reduce the eddy current losses, and this yoke made with cast iron, and this stator core stator core is made with cold rolled non non oriented silicon steel. So generally transformer is CRGO steel, cold rolled gain oriented, but it is a cold rolled non oriented silicon steel. That's the difference between alternator and synchronous generator. So it's already discussed. Yoke is made with cast iron, and core is laminated to reduce the eddy current losses. And this is made with cold rolled non oriented silicon steel. This is the material is used to construct the stator. And the inner periphery is slotted to accommodate armature winding. So the stator will be like this generally. Stator will be like this, and this inside inner periphery, nothing but in this inner periphery, armature winding is accommodated. So this in this way armature winding is placed. This is all about the stator, and this stator is common for salient pole and a non-salient pole rotor. So I will explain later. So, but in this armature winding, this in these slots, armature winding is placed. That winding, uh, that winding is uh, two types. That is, one is distributed winding, another one is concentrated winding. Full pitch winding, that is distributed winding, again full pitch winding and short pitch winding. This distributed winding is used to eliminate higher order higher order harmonics, such as 11th, 13th, like that. All higher order harmonics can be eliminated by using this distributed winding, and by using short pitch winding, we can eliminate 5th, 7th, 9th harmonics, especially whatever we want, which one is dominating more. Such harmonics will be eliminated by using the short pitch winding. and this third harmonics are dominant harmonics eliminated by using star connection, and between line to line, this is RYP, between line to line, and VRY, nothing but R to Y voltage, line voltage. Between these two voltages, three third harmonics third harmonics automatically eliminated automatically. So automatically eliminated this harmonic, like the third and fifth, seventh, ninth, and all higher order harmonics. So third with the line to line voltage, fifth, seventh, ninth with short pitch winding, and higher order harmonics will be distributed winding. So in this way, to eliminate the harmonics, we should use such types of winding. So now let us discuss the rotor construction. So there are two types of rotors will be present. One is salient pole synchronous machine. If you use salient pole rotor. So another one is cylindrical rotor, round rotor. By using this one, the machine is called cylindrical synchronous machine, or non-salient synchronous machine. So for these two machines, stator is common. Stator is common. There is no difference in the stator construction. So you can see here, and the two types of rotors are, you can visible clearly. You can observe clearly. So here, this length of the uh, this is a cylindrical or round rotor. This is the cylindrical rotor, round rotor. Length is more, but the diameter is less. Look at this one, diameter is less. But here in this salient pole, salient pole, this diameter is less, and this is nothing but a length. You should not say length, axial length. Axial length is less in compared to the cylindrical type rotor. So another important thing is, the most important thing is, between these two, you need to remember. Look at this one. This is uniformly it's like a solid in nature, but here one pole to one another pole, some gap is available. You can observe gap here and here, like this, the gaps are available. So that the gap is called as a saliency. That's why the gap is called saliency. That's why this named as salient pole rotor. Nothing but poles are placed between the gaps. That is nothing but a salient. So these are the two types of rotors, and field winding is provided between the. You can see here also field winding is available here, for the slots, for this poles, field winding is available. For these two rotors, field winding is available. And I will let us discuss in brief about salient pole or non-salient pole. So you can see, clearly observe, this is the gap is available. Here also gap, here a gap, here gap is available. This gap is called saliency. And around this surrounding of this pole, surrounding this slots, winding is placed like this. This winding is called field winding. For this field winding, we should give the DC supply through through split rings. You can see this split rings here. You can clearly observe the split rings here. So here split rings are available. So here through these two split rings, So we need to give the DC supply to the field winding, and this rotor rotor core is laminated, and also in the pole faces here, in these pole faces, here, damper damper bars are winding. Damper winding is specially used to prevent the hunting. I will explain this hunting later. So hunting is defined as a uh, oscillation of rotor. Hunting is defined as of oscillations of rotor at equilibrium position. So that is nothing but a hunting. So I will explain that later. So to prevent the hunting, we should use damper winding, and separately we should use damper winding in this salient pole alternator. And these alternators are used in so where these alternators used means hydroelectric power plants, HPP, hydropower plants, nearly in Srisailam, Nagarjuna Sagar, Jurala in Telangana, and if you take Himachal Pradesh and uh, in Orissa, Bakranangal, Terai Dam is there. So in such a places we should use thermal power plants are available in such a places. There we should use hydroelectric power plants. In these hydroelectric plants, you can see this setup. So you can see the setup here. This is the turbine, and these turbines are mechanically coupled to the alternator. This alternator is nothing but alternator rotor is salient pole type of rotor. Salient pole type of rotor is used in the hydroelectric power plants because this is suitable for the salient pole rotor is suitable for low speeds, 50 to 300 rpm. Why? Because so this diameter is more, and also the rotor poles are projected outside like this. So I draw here. So the poles are projected outward like this. So this is a salient pole, and between the pole to this is north pole and south pole, between these poles gap is available. This gap is called saliency. This gap is called saliency. So this diameter is more. If the diameter is more, we can place more poles. That's why diameter is more poles are required, because the synchronous speed is equal to 120 f by p. If number of poles increases, then speed will be automatically decreases. But for the low speed, sorry, for low speeds, if you use more poles, then you can achieve the synchronous speed. I will differentiate that one with an example later. And here, if you rotate this rotor at higher speed, for example 1000 rpm and 2000 rpm, like that, due to the centrifugal action, because due to the gap is available here, so that due to the centrifugal action, these poles due to the centrifugal action, these poles produces the vibrations, so that we should not use this salient pole rotor for high speed. We should use always for the low speed, because low speed. But in hydroelectric power plants, low speeds are only possible because so that potential energy, because this is a dam is constructed, and water passes through the penstock to the turbine, and we cannot increase the water speed, because naturally water falls, so that the speed is naturally certain speed only. so we cannot increase the speed. In thermal power plant, in thermal power plant and nuclear power plant, we can increase the speed by increasing the temperature. So there we can increase the speed, but in this hydropower plant we cannot increase the speed. So I will explain the difference of why it is used for large diameter, and the salient pole is more diameter and non-salient pole is less diameter. So let us discuss that comparison. So you can see that comparison. You can see the comparison, and so for example, the speed, sorry, frequency. Let's take a frequency. F must to be 50 hertz, and by using salient pole, this is the synchronous speed. Ns is equal to 120 f by p. From this one, f is equal to pn by 120. So the product of poles to speed ratio, pole to speed must be constant, so that we can achieve constant frequency. For example, I am taking salient pole rotor. Here diameter is more, so that more poles, 1, 2, 3, 4, 5, 6, like that, more poles are available. More poles are available. So to get 50 hertz frequency, and RPM speed, RPM of this one is this is 300 RPM. I'm taking 300 RPM. We don't know the poles by 120. 120. Now the P is equal to 120 into 50 by 300. So these two zeros and one zeros, three ones are, three fours are. So 4 5s are 20 poles. You can see here 20 poles, more number of poles. So for 300 RPM, for 300 RPM, to get constant frequency 50 Hz, it requires more poles. More poles, that's why the diameter, if the diameter is more, we can place the more number of poles like this. Simply if the radius is, diameter is more, we can more number of people can sit. So if you take a cricket ground, if the diameter is this is the diameter is more, then more people can sit, occupy, more people can occupy the places. So this is that's why the diameter should be more. But in case of a high thermal power plant, the speed is more. So to get 50 hertz frequency, to get the 50 hertz frequency, we don't know the poles into the speed of thermal power plant is not 300. This is about uh, due to the high pressure of stream, and the speed must be high. That is the speed approximately 1500 to 3000 rpm. I'm taking 1500 rpm. I'm taking 1500 by pn by 120 here. So number of poles p is equal to 50 into 120 by 1500. So 1010 again, 110, 5 ones are 5 threes are 3 ones are 3 fours, nothing but 4 poles are very less. We can see here 4, only 4 poles are available. So to place the only 4 poles, the diameter is very less. Diameter is very less. Only 4 pole, 1, 2, 3, 4. So if you use more diameter, and then more poles will be available. So my conclusion is for salient pole, nothing but by using in the hydel power plants, that speed of turbine is less, so that if you use more poles we can produce as 50 heads, only 50 heads. So even if you have less speed, if you increase the poles by increasing the diameter, we can generate electricity at 50 hertz. But in the thermal power plants or nuclear power plants, speed is high. High speeds are possible, so that if you use a diameter, if you use the less diameter and more axial length, I discussed it, this is the only classification based on the diameter only. Now let us discuss of the axial length. So Look at this one clearly. So here diameter is more, but axial length is less. Even though we can place the here here winding, here also we can place the winding, here also we can place the winding. So this is approximately, I'm taking, this is axial length of the stator, I'm taking, this is up to approximately a stator I'm taking. So this is a more number of, here the winding is placed in the slots of stator, but the diameter is more, but length is less, the axial length is less, diameter is more. So that but here in the non-salient pole, diameter is less, but axial length is more. So that here we can compensate the winding. So whatever the, nothing but for the same rating, for same rating we can use a salient pole and non-salient pole. But here diameter is less, so that diameter is more in the salient pole. So that here more number of slots are available here. So that we can place the total winding. But here less number of slots are available, but the length is more. So that whatever the winding is placed here, which is equal similar to this winding, but the only case is here diameter is more, here axial length is more. That is the only difference. So this is all about the salient pole alternator, and you can see the cylindrical rotor here, and cylindrical rotor also you can see these slip rings are available here, and through these slip rings this is field winding. Field winding is like this. Look at the length, you can see the length is more, length is more. This is nothing but an axial length, axial length. So the, you can see the here for large length you can see this more number of nothing but a large length of coils are placed. So here cylindrical rotor information. So this is used for high speed. I already discussed for 4 poles 1800 rpm and 2 poles 3600 rpm. This is for 60 Hz frequency, not for 50 Hz. For 50 Hz this is 3000 rpm, and this is 4 poles 1500 rpm. You can see here speed is equal to n is equal to 120, f is 60, by poles are here, 2 poles are available, 2 ones are 2 6 60, 66 3600 rpm. So that this is 60 hertz. If you use 50 hertz, n is equal to 120 f by 4. 4 ones are 4 3s are 3 1 3 15s are nothing but 1500 rpm. If you use 4 volts 50 hertz, the speed is 1500 rpm. So this is a and also another point is there. So direct conductors cooling is used. So nothing but hydrogen cooling or water constant cooling. So in general, hydropower plants and thermal power plants, due to the eddy current and due to the copper losses, some temperature will be produces. Temperature will be produces and the temperature increases. But to reduce the temperature, this cooling system is used by using hydrogen or water cooling. So the rating is approximately 2000 MVA. So for such a rating, this alternator is used, alternator rotor. So let us discuss the comparison between these two rotors. I already discussed that construction. Now let us discuss the comparison. Let us compare the salient pole and the non-salient pole type of rotors only. So this is used for low speed. Salient pole rotor is used for low speed, and this is for high speed. Because this is a salient pole is low speed because poles are projected outside like this. So that if you use it for high speeds, due to the centrifugal action, and these poles produces the vibrations. That's why these rotors are used for low speed. For example, if you take four wheel or two wheeler having, if the diameter of the wheel is more, this is used for low speed only, nothing but at the starting of the vehicle it is low speed. So look at this one, this is high speed. High speed is nothing but the diameter is less and axial length is more. So if you know the scooty, if you know the, you know very well about the scooty, two wheeler vehicle, two-wheeler vehicle is it? This is, so this vehicle will produce high torque, high torque, so that at starting high speed is possible because diameter is less. The diameter is less, high speed is possible. So that's why this non-salient pole diameter is less. That's why this is used for high speed. The next one is the air gap is non-uniform, and so you can see that clearly here in this figure. You can see that a uniform air gap is present or not. So here air gap is uniform because there is a gap, there is less gap, and there is a very less gap, nothing but in the for ventilation purpose only. But here separate gap is provided here in this salient pole rotor, gaps are provided. That's why air is not uniform because here and less air is there, here more air. So that's why this is the important point. Uniform uniform air is present in the non-salient pole, and non-uniform air present in the non-uniform air gap present in the salient pole. And diameter is more, axial length is less, such I discussed that one. This is here is opposite, and poles are projected outside of the rotor, nothing but which is poles are projected outside. You can see here, this is pole, and this is pole, and this is pole. So this is actually rotor, and this is pole. So these poles are projected outside. So that is projects are poles are projected outside, but here poles are not projected outside because the poles are inside. So you can see here this is poles are not projected outside in the cylindrical rotor, and this is mechanically weak because this is used for only low speeds. If you use for high speeds, due to the centrifugal action, the poles produces the vibration. That's why this is mechanically weak, and that is mechanically strong. And separate damper winding is placed. Again, separate damper winding is placed to reduce the hunting so hunting, and also uh, to produce reverse harmonics and reverse power, to produce to reduce the uh, this is vibration. So this damper winding is placed, and here in the salient non-salient pole, field winding itself act as a damper winding. So I will explain about the damper winding in the next slides. So why the use of, what is the use of damper winding? So this separate damper winding is not used in this non-salient pole, but in the salient pole, separate damper winding is used. So if you know if you uh, look at the applications, this is application. This is used in hydro power plants, and these are used in non-salient pole is used in nuclear power plants and thermal power plants where constant speed is required. So, this is the next one is the phase sequence. What is phase sequence? The phase sequence is the order of production of maximum EMF is called a phase sequence. So that is RYB or ABC. This is represented in terms of RYB or ABC. So that is nothing but the phase sequence is nothing but this is R phase. I'm using it red one. R phase. This is R phase is like this, and the next one is Y phase. Yellow phase will be produced after 120 degrees. This Y phase. Next one is blue phase. Nothing but B after 120 degrees. This is not from this point. This is 90 degrees, and this is approximately 120 degrees. After 120 degrees, B phase. So the production of maximum EMF. So this is the EMF axis. So here maximum EMF R phase. This is Y phase, B phase, or A phase, or B phase, or C phase. So order of production. So first the maximum is R phase, and then Y phase, and then B phase. This order R Y B. This order is called as phase sequence. Phase, nothing but RYBR or YRB. Sequence, nothing but production generation. So that sequence is called phase sequence, and thus phase sequence of alternators is independent of field polarities. This is very important. So if the field polarity is like this, positive and negative, and at this position the phase sequence is RYB. Now, if you change the field polarities like this, negative to positive, then also the phase sequence is RYB only. So this is important for your competitive exams also. And another point is the phase sequence can be changed by changing the rotor rotation. Nothing but if you take this is rotor, north pole and south pole. If it is rotating in this direction, the phase sequence is R by B. If you rotate in the anti-clockwise direction, then the phase sequence is R B Y. The phase sequence is changes. So this is for alternator. So to change the phase sequence, alternator must be rotated with reverse direction. Nothing but rotation must be changed. So if you change the direction of rotation, phase sequence instead of RYB, it will produces RBY. So look at this one. This is the RYB. So this is phase sequence of RYB. So in this direction RBY. So to produce the reverse phase sequence, we should rotate in the reverse direction. But if you change the polarity, field polarities, it will not affect. And the last one is this is related with the DC motor. DC motor. So the direction of the rotation of a synchronous motor. So synchronous motor is rotating in the clockwise direction, but if you want to rotate, if you want to change the direction of rotation, you need to give the changing frequency. You need to change the phase sequence. That is I think, but by changing the phase sequences, for example, if the RYB phase sequence is rotating in the clockwise direction, if you change the phase sequence to RBY, it will rotate in the anti-clockwise. So this is about DC synchronous generator. This is about synchronous motor. So this is all about the synchronous generator phase sequence. And what are the advantages of keeping the armature winding on stator? But this armature winding of DC generator placed on stator. So this is stator slots are available like this, and we need to use the stator winding here. And in the rotor side armature winding is used. Sorry, this is in the stator of DC generator. This is the poles are available, and like this poles are available in the DC generator stator, north and south. In the rotor armature winding is placed, and here two split rings are used to produce the DC output. DC output, but to produce the AC output, we should use slip rings. By using slip rings, we can produce single phase AC. But in DC machines, if you want to provide three phase AC, we should use for one phase, we should use two slip rings. For one single phase, in DC generator, if you want to produce a single phase, we should use two slip rings. By using split rings, it will convert the internal AC to pulsating DC. This is split rings. But slip rings, it will convert internal AC to output also AC only. But for three phase, we should use slip rings. Six slip rings we should use it. Uh, but in the synchronous generator or alternator, by using these two, bulk amount of power can be produced. Bulk amount of produced, the amount of current is produced, and the bulk amount of power will be produced, and because of that one, in the slip rings cannot carry the current, and due to the commutation failure and commutation problems will be takes place. And also six slip rings are required, and these six slip rings will not collect the current accurately, and these slip rings will get damages due to the high currents of the synchronous generator or alternator. So to avoid such a problem, we should use this armature winding on stator. If you place this armature winding on stator, mm, slip rings does not required on the stator. So this is a rotor. For example, this is rotor of the alternator. Four poles are available like this. So this is stator, and in the slots armature winding is placed, and outside RYB phase. Whenever this rotor north and south, and this is north and south, and again north and south, this will rotate, and it will cuts the stationary conductor. It will produces the RYB three phases. And to give the supply to the rotor, we need to give the DC supply to the rotor through split rings. So here only two two split rings are used for if you place this winding, nothing but armature winding on stator. So if you place this armature winding on stator, what are the advantages? Only two slip rings or split rings used for to give the DC supply, to field of rotor. Only two slip rings are enough instead of six slip rings. And current collection is easy, because current collection is bigger because easy, because here topic separate slip rings are not available. Only direct you can collect the current from the RYB phases, so that it's very easy to collect the current. And the generation of power at a high level is possible, and high level power supply is possible because current collection is easy. And the insulation and cooling arrangement also very easy, because uh, if the armature winding placed on the rotor, it is very difficult to place the cooling system. Nothing but if you, it is very difficult to circulate the hydrogen or water in rotor. It is very difficult to arrange the water in the rotor. That's why this placing of the cooling arrangement is difficult in the difficult if you place the armature winding on rotor. So insulation also you can easily arrange it, because outside you can, this is stationary part, so that insulation is placed very easily. Next one is low level of field. Nothing but the field supply is less, so that insulation required also very less or low. So that is another important point. And the last one is no commutation. No commutation is required. No commutation is required because we are not collecting currents by commutator. commutator, nothing but commutation action. Commutator is not required because directly current is collected from the stator winding. These are the advantages of placing armature winding on stator. In the next classes we will discuss hunting and why what hunting is will be produced and how to eliminate the hunting.